Great. Hi. So, do you remember when you saw the current generation of language models for the first time? Because I certainly do. It was sort of at the end of the summer in 2022, and I went to this hush-hush meeting where I was going to get a demo of the latest OpenAI model that had just finished training. And I knew going into this meeting that I was going to be responsible for taking the model and integrating it into Microsoft's core productivity products like PowerPoint and Word and Teams to create the future of work. But I was also deeply skeptical. People were really excited about what this model might be able to do, even though they hadn't seen it yet. But I knew from decades of research on AI that people's expectations tended to pretty significantly supersede what the models could actually do. So I'm in this windowless conference room on the Microsoft campus, and I'm there with Sam Altman, who's the CEO of OpenAI, and a handful of folks from Microsoft, including our CEO, Satya Nadella, and our CTO, Kevin Scott. And Greg Brockman, who founded OpenAI with Sam, takes a news article off the web, and he copies it into the model's context window. And then he asks the model to summarize the article. And this is something that state-of-the-art models at the time were actually pretty good at. Abstractive summarization was sort of an emerging capability of those models. And it was also the kind of thing that would cause me trouble, because it would get people's expectations up and demo well, but didn't tend to hold up to scrutiny. And then Greg started asking the model questions. He asked the model to turn that summary into a poem. And then he changed the rhyming scheme of that poem, and I asked it to change one of the lines in the poem. And one of the things that became clear as we iterated with the model was that it was able to hold context over the course of the conversation and handle ambiguous instructions. And that was new behavior. So imagine, for example, asking the model to create a sentence where every word in the sentence started with the letter G, and it was about Microsoft. This is something that was really hard for language models at the time because it requires carrying constraints over long text sequences. But this new model was able to do it. And what's more, it was able to do it and figure out that it was supposed to break the rule for the word Microsoft, because you couldn't write a sentence about Microsoft without a word that started with M. But I also found I could iterate with it. So if I decided that that rule, that every word starts with G, was more important, I could tell the model, and then it would rewrite the sentence decentering Microsoft so that every word started with the letter G. And the more that I played around with this model and tried to break it in all the usual ways, the more it became clear that this is really something different. Now, I don't live very far from Microsoft campus. I'm only a couple miles away. But headed home from this meeting, I found that I actually couldn't make it the whole way home. I had to pull over halfway there and stop in the parking lot of a 7-Eleven, and I sat in my car in the 7-Eleven parking lot, and I screamed. And I screamed because I realized this wasn't a fool's errand that I was on. I had the opportunity to help create the future of work. We were going to be talking to our computers. I screamed because I felt a huge responsibility to get this technology into people's hands quickly. And I screamed because I felt a responsibility to do it in the right way. And so I screamed, and then I went home and I drank. And that began the mad dash to create what's now M365 Copilot. But while that meeting that I was at represented a really significant shift in how I viewed things, it's important to note that it wasn't out of the blue. It was part of a long technological progression. A lot of innovation got us to that point. And it actually makes me think of another really important technology that came around a fair amount earlier. I don't know if you remember the first time that you saw a web page. You probably don't, but I actually do. I was in this dungeon of a computer lab at my undergraduate institution, and this guy calls me over. He's like, Jaime, come check this out. And he showed me my very first web page through the Lynx browser. And if you haven't used the Lynx browser, it's entirely text-based. You have to like tab around to get between links and click return if you want to follow a link. Honestly, I thought it was really dumb. I fortunately wasn't too dumb to realize that guy was something special, and we're actually now married and have 4 kids. And I came around about the web as well. And here's why. You've probably heard that AI is enabled by scale. Well, it's the web that has enabled a lot of that scale and made it possible. So the basic approach underlying deep learning, it's been around for a really long time, since before I did my graduate work. To learn something, you basically take data and you feed it through a network of weights, performing a bunch of calculations, and then you look at whether the output of those calculations match some label. And if the output matches the label, that's great. And if it doesn't, you go and adjust the weight so that the next time you feed data through the network, it'll look a little bit more like the label. And if you want to do complex reasoning of the form that I saw in that meeting with GPT-4, you need a lot of weights, which means you need a lot of data, which is where the web comes in. And so, of course, it's required a bunch of innovation to take that kind of data, text data, and turn it into something that the model can learn. Like one thing that we do is to create labeled data from this unstructured text is we might mask one of the words in a sentence and then treat it like a game of Mad Libs. Essentially, the model has to guess what that masked word is. The masked word is the label, and the training data is all that's going into that. And that's called unsupervised learning. But really, the meta point here is that to get to a point where you see emergent, interesting, complex reasoning in a model, you need to do a lot of innovation over decades. And you can't really understand where you are or where you're going without understanding all of that history. And so, following the meeting, my job is to figure out how to integrate large-scale generative AI into people's productivity tasks. And the good news is I essentially got to cheat using that same mechanism that we were just talking about. There's been a ton of research, decades of research. Since basically before computers even existed, people have been studying how computers can support productivity. Microsoft this week is actually turning 50, so as a company, we also have decades of knowledge. And while we have to look at everything that we know through a new lens with AI, we have to understand that research and that thinking a little bit differently. What it means to be human and work and get things done, that's sort of foundational to what we are, and that's not changing. So what do we know about work that we get to build on? We know that work is purposeful. We know that work is persistent. And we know that work is collaborative. So let's start with the fact that work is purposeful. Everything you do has a meaning behind it, has an intent, has a purpose. Nobody, for example, goes to Excel to create a pivot table. They go to Excel because they want to reason over this quarter's budget. It's only an artifact of sort of the limitations of computers right now that we have to translate that intent into a set of actions that the computer can understand. And the cool thing about language models is they actually allow us to skip that. We no longer have to translate our intent. Instead, we can express it directly. But there's something else that we know about productivity and purpose. And that is that expressing intent is hard. For complex intents, in fact, people often don't know in advance what they're trying to do. And this means that using AI can be metacognitively demanding. You have to figure out what your intent is. You have to figure out how to express it. You have to make a plan about how you're going to go about getting it done. You have to be able to evaluate the output. And it's a lot of work. The interesting thing is that AI is actually quite good at that metacognitive process as well. So a lot of the way that we're using AI right now is sort of like in that old school paradigm where we're like trying to tell the computer what we want it to do and expecting the computer to go do it. But there's a real opportunity to go forward, to start thinking about AI as a thought partner. And so the next time you use an LLM, I actually encourage you to explore the way that it can challenge your thinking. So that's a little bit about how work is purposeful. Let's now look at how work is persistent. And Microsoft essentially came into existence as a document company. We exist so that people can create documents to persist knowledge in an electronic form. And the interesting thing with language models is that you're seeing the kind of knowledge that is getting persisted is a little bit different. It actually looks like natural language, whether that's in the form of a chat or whether that's in the form of a transcript. People are creating knowledge through conversation. A good example of this is Copilot Pages, which will turn a long conversation that you have with Copilot into a persistent artifact based on the knowledge that is generated in that conversation. Another thing that we see is we actually see our customers not going to create documents directly, but instead, when they have a document they want to create, like a PowerPoint deck or a Word document, they might schedule a brainstorming meeting to get together with their team and then talk about what the information is that they want in that artifact and rely on Copilot to translate their conversation into that artifact. So documents are getting created differently through conversation. We also see that documents are getting used differently. Increasingly, people aren't going to documents to read them. They're going to documents to get summaries and ask questions of them. Or what's more, they might take a set of documents related to a topic or a project and use that set of documents to ground a conversation. Web search is a great example of this, where you see more than doing web search, people are having conversations with language models and relying on the language model to identify the searches that need to be run, gather that information, and use that to ground the conversation. So documents still matter. They're just getting created via conversation, and they're getting used via conversation. Which brings us to collaboration. The thing that really drove home to me the importance of collaborative work in the context of language models was when we started integrating GPT-4 into Teams and seeing the impact that it had on the meetings people were having with others. It's like, imagine, you've probably mostly been using language models on your own for your own work. Imagine having a conversation with another person and being able to get feedback and support on that conversation in real time based on the conversation. So like if you're having a disagreement, getting insight into exactly where you're disagreeing and like the kinds of questions that you might be able to explore before the conversation is over in order to align. These are real opportunities. But as powerful as collaboration is, I get particularly excited when you think about how language models can unlock collaboration in the cases where collaboration actually starts to break down. So collaboration matters, but sometimes collaboration doesn't work. When does collaboration not work? Collaboration breaks down at temporal boundaries. If you're on a different time zone than I, collaboration is harder. In fact, even if you're a night owl and I'm an early bird, collaboration is harder. And we're seeing people use AI to start to break down the boundary between synchronous and asynchronous collaboration. Like, this shows up in like simple ways where people are getting summaries from meetings that they weren't able to attend. But we're starting to explore more complex ways as well. Like, what does it mean to send a delegate of yourself with AI to a meeting that you're not able to attend to represent some of the things that you're thinking about? Another place where collaboration breaks down is at scale. You know, there's a reason that like the perfect dinner party size is 8 people, because like 8 people is the most that you can chat with or have a good conversation with. That limitation doesn't apply to large language models. They can handle natural language input from way more than 8 people. A good example of this is, think about restaurant reviews. You know, when you want to choose a restaurant to go through, it's hard to go through hundreds of restaurant reviews and figure out what's going on there. AI, on the other hand, has no trouble going through all of those reviews and figuring out, like, hey, people think this restaurant's a little bit loud, but the vegetarian food is amazing. Imagine as we start figuring out how to use AI to get this sort of collective intelligence in more structured ways. These are big changes that are coming up. And big changes take time to realize. You know, our future selves, many years from now, we're going to look back at this moment, and we're going to be surprised at all the things that we don't know are coming that are obvious to our future selves. But we do know big changes are coming. And the reason that we know these big changes are coming is we're already seeing significant impact from AI on how people are working, even though these tools are brand new. So for example, the very first Copilot customers, you know, the people who sort of got access to Copilot licenses before they were available to anyone, they worked with us to randomly allocate those licenses to their employees so we could run a randomized controlled trial of the impact that generative AI would have on work. And this allowed us to make inferences that were statistically valid and causal. And when we look at that data, we see really significant shifts in people's work practices. We see, for example, that with Copilot, people created 10% more documents, and they read 11% fewer emails. We have been seeing change like this before in laboratory studies, but those are places where, like, where the experimenter has a lot of control over what's going on. They define the task, they define the context. This is behavior change in the real world on the tasks that people are actually doing. It's shocking to see that just a year or two into a brand new technology. And you know that the impact is going to get bigger because, honestly, this is people using AI in the most boring way possible. I mean, nobody imagines that the future of work is going to be us using AI to generate more content so that other people can use AI to summarize that content. AI is making us more efficient at the things that we know how to do, and we need to be taking that time that we get back not to do more of exactly what we know how, but instead to do new things in new ways. We know that work is purposeful, and AI can help us use natural language conversation to discover new intents. We know that work is persistent, but what persists is not documents as much as the knowledge that we generate through conversation. And we know that work is collaborative, which means those conversations are taking place not just with AI, but they're taking place with other people. So the future of work is not about doing more things faster. The future of work is about having interesting conversations. Thank you.